Hello everybody, day 2 of log applications, and today should be pretty straightforward. It's day 3 with the Newton's law that is really interesting, so can't wait for that one. Actually A through D that is all review. You can do this. See if you can do it. Actually, go ahead, hit pause if you want. I'll give you a sec. Write the equation that models compounded interest that we did a week ago or so. Okay, hopefully you wrote A, the amount I have at any point in time, is equal to P, my principal, 1 plus R over N to the NT power. And don't forget what these parts are doing is the R over N converts annual to, like, I don't know, monthly interest or whatever the period of MONTH monthly. And then this NT converts from a number of years into some period, like a month or something like that. Okay, so go ahead and do it. Use the formula to calculate annually, quarterly, monthly, daily, continuously. Go ahead and hit pause. This is the chance just to warm up on word problems again to make sure you're good at it. Don't forget, I think I'm going to go ahead and just type in here so I can have 5,400 times, and I'll work them that way. So go ahead and hit pause, and I'll be back in a sec. Actually, go ahead and hit pause. Hopefully you're working them. I wonder how I pause my recording. So you don't have to wait for me to do this, but I don't know how to. So if you want to fast forward past me working these out, that's fine. That's a nice feature of the thing. 1 plus 0.06. This is annually, right? Raised to the 15 years equals. Okay, I can delete that. I'll make it red so it stands out better. Actually, where's my home? Now I should be able to just go down here, paste that. Oh no, what happened? Should just copy the formula. And this one is changing into quarterly, so it's divided by 4. This one's raised to the 15 times 4 equals, yep, that looks right. Round that up to 9. Copy this portion of it. Come over here. Change this to 12. Hopefully nobody's actually watching this because you can just fast forward past this. Hopefully you're just checking your work and you all got it right before I did this. And set that around to 11. And then just go right here. 365. 365. Gee, can I make this bigger? I'd rather it didn't wrap. There we go. 7's good. Now, hold on. Now, here's the pattern we want to note at this point. Let me make this bigger so we can see all these numbers. Notice what's coming back in here. This, that number, and the original number. Notice going from annually to quarterly and just adding interest on top of interest, I'm going up 60 bucks. That's like 250 bucks more. That's pretty good. And that's only 4 times versus 1 time a year. Big difference. Now I go from 4 times a year to all the way to 12. I made another, how much money? Another 60 bucks, not 250, but I made another 60 bucks. Then I go from monthly down to daily, and how much more is it? Oh, not even $30 more. So somehow the amounts additional, I'm earning interest on interest more frequently, but the amounts seem to be going down. So could I add interest to the account every hour? How about every second? How about every microsecond? If I do every microsecond, in one day we're going to be adding interest hundreds of thousands of times. What if I did it continuously? And this is a good concept to get as you're thinking about moving into calculus, which is all about continuous change and infinitely small periods of time. There is a magic formula that is similar to the blue formula you wrote up here that we use for continuous compounding. And to actually derive this, you need calculus. And that's why natural logs, the other day I said, were so important as you think about moving into calc. But so it starts out with a equals p, just the same as up there. But instead of this 1 plus r over n, it has the magic e to the RT power. Why? Oh, it's magic. I don't know. We'll see. But if I use that formula and I type things into it, the same numbers, I'm still starting out with 5,400. E is E, so whatever that is. The rate is still the annual rate of 0.06, and I'm still doing it for 15 years. Type that in your calculator, see what you get. Hit pause. Do it, and you should get, actually the number I have written down here doesn't, you should get 13,200, dang it, jumpy thing. My pen tip's about trashed, so hopefully I can actually continue writing here for the next couple days that I need it. 281.86 I think is what I got, which compared to daily, what was daily? It's only like $1 more, 99 cents more. Not that much more for adding interest, in this case, an infinite number of times, which if you actually think about it, being able to do a calculation where you added interest in an infinite number of calculators, even the best supercomputer couldn't do that. But we can do it using calculus, which is a really cool and powerful idea. But we'll save that one for a year or two. Okay. Now, you want to have after 12 years. So this is not, of course, 35,000 is no longer P. It's the A I want. So this is also review, C&D review. If you haven't done it yet, go ahead and hit pause. Try to work it out, and then come back to me. Okay. When you work C, you should have 35,000 equals unknown principal. This is like maybe you're saving for college. The rate was 1 plus 0.05 daily, so 365, and then 365 times what, 12 years? Now when I solve that, I can get a decimal for this whole parenthesis raised to a power thing, and I'm going to basically do 35,000 divided by all that stuff, and I'll get P equals 19,209.20. Okay, not a bad deal. Put in 19,000, come out with 35,000, and that's the power of compounded interest and saving early for retirement and all those other things. Okay, you deposit 1,500. How long will it take you to reach 2,000? Now this one's interesting. I'm solving for something very different here. How long? This you haven't done before, but let's write it out. So how long to reach 2,000? That's the amount I have at some point in the future. 2,000 is equal to my principal at 1,500. 1 plus 0.03 over 4, since it's quarterly. Raised to the nt, so it's still 4 times t. Now, how do I solve for this t up here? Well, this is take the log of both sides and do the mapping thing. And don't forget, before you log this thing, you want to go ahead and divide by that 1,500, get the exponential all by itself. And what is, if you think about it, 3 500s make 1,500 and 4 500s make 2,000. So Now we can log both sides and log that side. Well, that's gone. Log that whole side of the equation, and you should see that we're going to get to have the log of what reduces to 3/4 is equal to, and then the 4t comes on down the main line, 4t times the log, and then the 1 plus 0.03/4 is simply, if you want to write the decimal, you can, 1.0075. So it's just a log calculation process like we've done before. And I believe you'll get 9.62. Is it 6.1 or 6.2? 9.62. And then t equals 9.62 years. Not bad to make sure you're trying it. You can solve that and get the right answer. Just good review. Okay. So basically, same formula we've used since exponentials. You used this last year in Algebra 1. We're just using it now and we're solving for an unknown t, something we need logs for. So relatively simple application of logarithms. Okay, E. Another one of the compounded continuously one. We're going to be solving for how long it takes. So let's set it up. 10,000 equals 7430. Now remember, this is A equals PE to the RT power. So it's an E 0.05, and I'm solving for how long? So I need to solve that. Same deal as before. You're going to end up dividing both sides by the 7430. So if I do that, I'll have 10,000 over 7430. And I'm going to leave some space here, e to the 0.05t. Now when we're doing this, I could take log base 10, but there's a principle we learned. If I take the log base 10 of 10 to the 5th, hopefully I'll remember that as long as the base of the log and the power are the same, they kind of cancel each other out and you're left with 5. Just like the log base 2 of 2 to the 6 is equal to 6. Okay, now remember, natural log, we haven't used it as much. We did a couple days ago in the assignment, but natural log, ln, is the same as taking log base e. So when I write this, instead of writing ln, I'm going to write, well, I'll write ln on this side. How about that? And then on the right side, I'm going to say that's natural log is the same as log base e. Now the reason that's kind of cool to do it that way is the log base e of e to the 0.05t is simply, I want more space. I think I can just hit enter here. There, that's better. So the natural log, I don't want a decimal and rounding, I'll just leave it like that so I can type it all in at one time. And then I'll get, well, 0.05t. So t is the whole natural log of this mess divided by 0.05, and if you actually work that out, you should get 5.94 years. Okay, hopefully that's nice. At what average rate? We haven't solved for a rate yet, an unknown rate. We want to have a 350. What kind of return do I have to get from the market in order to make this happen so I can appreciate my money in 7 years this much? So let's do that. It doesn't have any compounding, it's just an annual rate. So this is actually the simplified version of A equals P 1 plus R to the T power. I don't need the divided by N and the NT. Or if you want to use the general formula, just consider N to be 1. So 350. Notice I can work in thousands. I don't need to have all those zeros there. It doesn't matter. 280. 1 plus R. Don't know R. T is 7. Same as before, solve for your exponential. Divide by 280. Divide by 280. And effectively what I'll just write it out. 350 over 280, whatever that is equal to 1 plus r to the 7th power. And if I'm going to solve for r, I got to cancel out the 7th power. So hopefully you're thinking outside the box a little bit. Well, why don't I just raise both sides to the 1/7 power? And that's all you have to do. So 1 plus r is equal to 350 over 280 to the 1/7 power. So, and you can do that in your calculator. So the R you should get is 3.24%. Okay. I think this one's just a practicing of them taking a log of both sides. So go ahead and set it up, hit pause, do G, just practice. Okay, hopefully you did it. Similar problem, it looks like I had the same numbers I had for F. We're just solving for how long there. So 350 equals 1 plus, now in this case it's 0.06 to the t power. Oh wait, I forgot. I knew I forgot something. I forgot my 280. 350 equals 280 times all that. So 350 over 280 equals 1.06 to the t. In this case, you could take the log base anything on both sides. You could take natural log of both sides. Let's be crazy. We're used to taking the log base 10. Let's just, for the heck of it, take the natural log. Doesn't really matter. So hopefully you see that t comes on down the line. So t will be equal to the natural log of 350 over 280 over natural log of 1.06. And when you work that out, what do you get? 3.829, call it 3.83 years. And we're all done. And hopefully that works out. Good luck in your assignment.